Today we're going to look at two constructions that both involve a tangent to a circle. So the first type of construction is going to be a tangent when our point is on the circle. So in our setup for this problem, the first thing you need to do is mark where you're going to put the center of a circle. A compass is a circle drawing tool, but it doesn't mark the center, it just draws a circle. The center is a very important point of a circle, so start by making a center, and then from that use your compass to make a circle. Okay. Doesn't matter how big or how small, but just kind of keep in mind Goldilocks. You don't want it to be huge, you don't want it to be tiny. As a drawing tip for you, when we need to draw a full circle, sometimes that's trickier for students than just drawing like the little marks we've been drawing. One thing that can help is to put as much pressure as you can on the point of the compass and as little as possible on the pencil. So the pencil will just lightly drag along your paper. And instead of actually turning the compass, which can get very wiggly with your wrist, hold the compass still and turn your notebook around in a circle. Some students find that to be an easier way. Learning a compass is learning a new fine motor skill. So like in kindergarten, you have to learn scissors, and kids are really awkward when they're learning how to use scissors, and they try to use both hands, and it's very weird. Learning how to use a compass is a new fine motor skill for you. So you just kind of have to work through that, and I can try to give you some pointers that'll help you out there. But for this construction, we need a center, we need a full circle, and we need a point somewhere on that circle. Now we're trying to create a tangent to the circle. So somebody remind me what a tangent looks like on a circle.
The line that brushes up.
Ready?
The full line.
1 point on the other side.
Yeah.
That brushes along the edge of the circle, just shares 1 point. What is true about a tangent to a circle that's going to help us find where this thing actually belongs? What's a characteristic of a tangent that will help us actually locate what this thing looks like?
Perpendicular to the center.
Perpendicular to the radius. So what we're going to do, our first step is going to be to draw an extended radius. So what I mean by that is we're going to connect these 2 points, but also go beyond the edge of the circle. Okay, so we're drawing in a radius, but we're going to take it beyond the edge of the circle. And then if our tangent is supposed to be perpendicular to that line, we now need to construct a perpendicular. So we're going to make a perpendicular to the point on the line. I'm not going to write out all the sub-steps for how we do this. We learned this construction back on day 2, so you may have them in your notes from day 2. We also used this yesterday, and I did write out all the steps again yesterday, so you might have them in your notes from yesterday. So I'm not going to write out all the steps of how we do this again, but we'll go through the process again. My handwriting's not good enough to keep on writing it over and over. So you can refer to your notes on an earlier day. But to make our perpendicular to the point, this was our parentheses. So for our parentheses construction, you're going to take your compass point and place it on the point that's on the edge of the circle. And you are going to make a mark to the left and the right. So we're kind of making parentheses around that point. Then, after you make parentheses around the point, we're going to place our compass point on one of those parentheses. You need to open up your compass at least a little bit wider than it was before. and place your compass point on one of the parentheses and make a mark with the exact same size compass. Go over to the other parentheses and make a mark. We've got an X, so we can put a point there. And if we connect that point to the point on the circle, we get a perpendicular, which will be tangent to the circle. In terms of coloring this problem, the only thing that would have to be colored, the minimum amount of coloring, would be that tangent line. Okay, so you could just highlight that tangent line, and that would be fine. If you wanted to color more, there's a lot more stuff you could color here. But the minimum amount of coloring to do in this problem would be to highlight out that tangent line. Okay? So there's only two main steps to this problem, but being able to make a perpendicular has kind of a few steps to its process as well. Questions on this construction? Our second construction today is going to be a tangent again, but this time our point is going to be off of the circle. So once again, we're going to need a circle. Whenever you make a circle, make sure that you mark your center first. It's really hard to find the center if you don't make that mark first. So mark your center first. And then you're going to make a point that is somewhere outside of the circle. And it doesn't matter how far away it is. Anything about Goldilocks? You probably don't want to like right next to the edge of the circle, but don't make it like a whole paper's width apart either. Kind of a medium width away from your circle. It doesn't matter. I mean, anywhere they'll be in a line. Right? You can always connect them with a line, whether it's horizontal or not. It doesn't have to be horizontal. So on this problem, we again want to make a tangent. We want to make a tangent that's going to go through that point and brush along the edge of the circle. So to just kind of eyeball what that's going to look like, we're kind of going for something like this. Okay? But that's, I mean, I'm just like sketching. That's not like necessarily the right idea, but it's the right idea, it's not necessarily the right one. We could also do one along the bottom as well, the same kind of thing, but bump in the bottom of the circle. So that's what we're going for here. In the last problem we said a tangent should be perpendicular to the radius, but the problem is we don't know what point of the circle this is really supposed to hit. So that's our goal, is finding those points where this is supposed to hit. So I'm going to get rid of that since that was just a guess and go through how we can actually find this. I'm going to go through the step-by-step of what to do here. I'm not going to at first explain why we are doing these things. Actually, last night I was laying in bed awake listening to my daughter cry pretty much the whole night, and I was wondering, why does this construction work? I've been doing this construction for years, and I was like, what exactly am I doing when I do this construction? I don't know why I've been teaching this 8 years and that never bothered me before, that I didn't really know what I was doing. But last night while I wasn't sleeping, it bothered me. And I was like, So I came in early to work this morning and figured out why, and I will show you why, but it's easier to see why on the GeoGebra program than when you're actually doing it by hand. So I'll tell you the whys after I tell you the hows. Okay, so first we're just going to go through the step-by-step of how you do this. And maybe you don't care about the whys, but some people do. I was always a student who cared about the whys, so it surprised me that I had gone 8 years without asking myself why. So first thing we're going to do is connect the dots. Connect center to point. And you want to do that with a segment, so don't extend beyond them, but just directly connect one to the other, so you create the segment that connects them. Yes?
Isn't there really only one point where the line could brush against the circle?
There's one on the top and one on the bottom. We could have like a tangent that angles up and a tangent that angles down.
Okay.
So the next thing we want to do is find the midpoint of that segment. So yesterday, one of our constructions was to learn how to find a midpoint. So to find a midpoint, we said we're going to place our compass point at one of those endpoints. Again, I'm not going to write out the step-by-steps here. They're in yesterday's notes. But you're going to place your compass point at one of the endpoints and open up your compass to any width so long as it's more than half the length of the segment. If it's shorter than half the length of the segment, we're not actually going to get X's, so we wouldn't be able to have any dots to connect. I said yesterday one of the things I like to do is to open up my compass to the full length of the segment. Sometimes in this problem that doesn't work so good because sometimes that segment gets to be pretty lengthy. But you need to open up your compass so that it is at least more than half the width. Put your compass point at one end and make a mark both above and below. And place your compass point at the other end point and make a mark both above and below. Sliding all around. Okay. And then connect the dots. Not there. What?
Is it supposed to like not go through the circle?
Good question. That totally depends on how far away you put the point. It may be like mine and be completely outside your circle. It may be inside your circle. It may be looking like it's actually tangent to your circle. That all depends on how far away you put your point. So it doesn't actually matter compared to the circle where that line is. It could be outside, it could be inside, it could be brushing.
What if your X's aren't like equal? What if one's like kind of up here and one's like down?
Then your compass shifted at some point. So our midpoint then is about here. I think my compass bumped a little bit, so I'm not sure this is going to be perfect, but do as good as I can here. So our second step is to find that midpoint. Now, for our third step, what we're going to do is put compass point on the midpoint and set the width with your pencil on the center. Okay, so you're going to put your compass point on our midpoint, put your compass pencil so that it hits the center of the circle that we started with. Okay, compass point on the midpoint, compass pencil on the center of the circle, and mark on edge of circle. Okay, so I'm going to put my compass point on that midpoint. Oops. Put my compass pencil on the center of the circle. Very tricky with this little iPad compass here. And make a mark on the circle. I do top and bottom. You really only have to do one or the other. Mark those with points. And connect to starting point. Okay. You really only need one. So if the problem just asks you to find a tangent, just doing one of them is fine, but there's really two different possible ones that are going to go through the point we began with and brush along the edge of the circle. In terms of coloring your answer, the minimum coloring would just be shading in that tangent line, or if you do both, shading in both of the tangent lines. Questions on the how for this problem, and then I'll show you the why. All right. So I created the sketch this morning, so I wouldn't go through the whole process of it with you, but it looks pretty overwhelming here. So I did some things in color. So the first thing I did in color was this circle that is purple and this point over here. That was the starting information. Those were the two things that we began with. We began with a circle and we began with a point that was outside of the circle. Then we found the midpoint of this segment, which is these two large circles that kind of create that eyeball in the middle. That's finding the midpoint. So here's our midpoint. Then I set this as being the center, put the point of the compass here, put the pencil over here, and I marked on the edge of the circle, and I connected those 2 points. Now this is pretty overwhelming with all this. So GeoGebra actually has a tool, a feature to it that allows you to just find a midpoint, like it'll give it to you. Now if you're doing constructions with GeoGebra, you may not use this feature, okay? You need to actually do the construction to find the midpoint, not allow the program to do it for you, okay? It's trying to draw a segment here for me, I don't want. So I use the tool to find the midpoint because that gets rid of some of the messiness of the circles. Then we use this as a center and set our radius over here to get these 2 points of intersection. Now we said that a tangent should be perpendicular to a radius. So I highlighted a tangent and a radius here in green, and that should be a right angle. My question to you is why? How can we tell for a fact that that has to be a right angle?
They're supposed to be perpendicular.
Yeah, but how do I know they are? They're supposed to be.
You don't.
We do.
I favor theorem. Trust your eyes.
Back to when we studied circles.
Why the tangent?
To prove the radius in a tangent.
Theorem
2.9.
Half of what?
A radius is half of the circle.
Yeah.
So then if you just have to chop that in half to make an 90 degree.
A radius is half of a circle, but we can't compare a radius and an angle because they're different, things, a segment or an angle. But it does have to do with an idea of half. When we studied circles, we learned that a special kind of an angle is half the size of an arc, right? We learned an inscribed angle is half the size of an arc. This green angle here is inscribed in that large circle. Where are the edges of that green angle? What is that special line called? The diameter. So this angle is inscribed or put into a semicircle. A semicircle is 180 degrees. An inscribed angle is half of that. So we are guaranteed then that that green angle must actually be 90 degrees. That's the why. For anybody who's curious about why this construction works. The how is the 4 steps we went through, which is what you'll actually think through when you do these problems. But that's the theorem that allows us to know that we've actually accomplished what we were setting out to do.